Hey guys, we are looking at how we can add and subtract these rational expressions. And the key piece here is we are going to be looking for whether or not we have common denominators. That's going to be kind of a key requirement to doing these problems. And in fact, we must have common denominators which I'm going to abbreviate CD for whenever we add and subtract. And so we're going to talk a little bit about how we get that and then what we do once we have them. So when we talk about needing common denominators, we are going to multiply in any missing info. So whatever denominator is missing is going to get multiplied to make the two fractions have the same denominator. The one thing is we're not going to do anything with FOIL, so that's kind of nice. We're just going to leave everything in parentheses. Once we have common denominators, let's get rid of that epic line in the middle here. Once we have CDs, then we can just straight up add the numerators. So as I'm looking at this, 3x squared and 3x squared, that is common denominators. Same with x minus 4, x minus 4. The only wrinkle in this second example is that we have a subtraction problem, and in subtraction we have to distribute the negative. All right, that negative has to get in there, so it's going to become a negative 2x. Oops, kind of blotchy. Once we have that negative in there, then what we do, or then what we have really for that second fraction, is a negative 2x squared and a minus 7 up on top. So that's, I guess, another reminder to put in this top box, which is distribute the negative to the second fraction, right? Don't touch the first one. When we have subtraction. Okay. So I'm going to come back to that distributing the negative. Let's walk through this first one real quick, and then we'll kind of polish up with the second one. So because we have common denominators, we're going to add our two numerators. So we've got x to the fourth plus 3x to the third plus 4 plus x plus 3. And then all of that is over 3x squared. So it's a little more room to write. After we've hit that point, then it's just about like terms. And the only like terms I see here are 4 and 3. So x to the fourth plus 3x to the third plus x, and then those like terms to make 7 to seal the deal. The denominator, again, stays the same throughout. It is still 3x squared. Okay, so look for like terms, add those numerators, and then remember the denominator stays. So if we apply that idea to our second example over here, knowing that we've done the distributing of the negative here has given it so that we can now think about it as an addition problem. And again, we just are looking for what are our like terms. So I'm going to put these all into one fraction. Like so. And then in that one fraction, then we've got some like terms here. We've got 2 terms with x squareds and 2 constant terms for a total of 2x squared minus 6 over x minus 4. Okay, so that one had that extra wrinkle of having to distribute the negative, but we were able to manage it and we did just fine. The very last example I'm going to look at, by the way, pause right now if you need to walk through this or if you need to rewatch or whatever, because we're about to dive into how to get common denominators, which has a couple extra steps. And so I want to make sure your brain is fresh for that. So pause for a second, write down anything you need, write down anything you're missing, go back, watch anything that's unclear, and then get ready to dive into our final example, which is this one at the bottom. And in this example at the bottom, one of our denominators is x plus 7, and the other one is not. And so when I say multiply in the missing info, this second fraction is missing an x plus 7. So I'm going to multiply that second fraction by the x plus 7. The other denominator here is x minus 4. So I'm going to multiply the first fraction by x minus 4. Okay? And in doing so, now I have two fractions that each have a denominator of x minus 4 and x plus 7. And I said don't FOIL, just leave it in terms of epic parentheses. And then just distribute the tops, right? So the 4 times the x, the 4 times the 4, and then the 5 times the x, and the 5 times the 7. And now, because we have common denominators, we can just look for those like terms and look for how to combine them and finish the problem. So the 4 and the 5 are going to make a 9x, and the negative 16 and the 35 are going to make a 19. And then again, the denominator, it hasn't changed, x minus 4 and x plus 7. So added wrinkle of having to get common denominators in this particular problem, but we deal with it by just multiplying. So as you're working through stuff, keep that in the back of your mind. Let me know if there are things you need help with, because I want to take good care of you, but I think you guys are going to do great with this. Keep me posted.